All right, on page 46, in the next few lessons, you will investigate how to become a better learner and a better mathematical problem solver. Answer the following questions to reflect on how you already think about intelligence or smartness. So this is your opinion. How would you define intelligence or smartness? So intelligence is very similar to smartness. So how would you define that? So give me some sort of description of what you think smartness is. And then for B, do you think people are born with a certain level or amount of intelligence? Again, this is your opinion. Do you think people are born with intelligence or smartness? Do you think they're born smart? Do you think they're born dumb? And then do you think intelligence changes over your lifetime, or do you think it stays the same? So do you think you have the same level of smartness your whole life? Or do you think intelligence can change over your lifetime, meaning you can become smarter? And then for B, label the parts of the neuron. So for this one, a lot of kids put either neuron or cell body. Either one will work. And these are the axons. And these are the dendrites. The main job of something is to transmit information or messages. That's going to be the neurons. Main job of the neurons is to transmit information or messages. So basically, when you are learning something new, you are gaining more neurons in your brain. Your brain is actually growing. Information is sent from one neuron and flows across a gap called a synapse. So from one neuron to the next, information is passed on over this gap. And the axons carry information away from the cell body. So these bigger legs up here. So this neuron is going to carry information away, and it's going to connect to the dendrites of this neuron to take the information to the neuron. So the dendrites bring information to the cell body. The brain physically changes when you learn. Your brain actually grows. It grows more neurons when you learn. Something is a prime time for learning. That would be adolescence. Adolescence is when you're in your youth. So anywhere from when you were first born all the way up until like mid-20s. This is the prime time for learning. This is the best time to learn new information, which is why we go to school. Stronger and more complex connections make information transmission easier. So what this means is as your brain grows more neurons and makes more connections, it makes it easier for the information to go from one neuron to the other. So basically, as you are learning, it makes it easier for you to learn more after that. New and stronger connections are made when you work hard at something new. When you work harder, you get smarter. So when you're working on really easy stuff like 1 + 1 is 2, 2 + 2 is 4, your brain's not growing. You already know that stuff. But when you struggle with these hard math problems, your brain is actually growing, making you smarter. Then we're off to page 48. Okay, apply the skills and strategies you learned in the bike and skateboard problems earlier in the unit to the following scenario. Rectangular tables are arranged in rows with chairs around each row as shown in the picture. So we have one table with 6 chairs, 2 tables with 10 chairs, 3 tables with 14 chairs. There is a relationship between the number of tables and chairs in each row. With this in mind, answer the following questions and provide evidence for your answers. How many chairs would fit around a row of 5 tables? All right, well, let's take a look at the change that's happening with the tables. So as we increase by 1 table each time, we are increasing by 4 chairs. So let's make a handy dandy little T-chart. We've got tables, we have chairs, and 1 table has 6 chairs, 2 tables has 10 chairs, 3 tables has 14 chairs. So we could continue this pattern for 5 tables, 18 and 22. So 22 chairs. How many chairs would fit around a row of 11 tables? All right, so we can continue with this, or we can try to find a pattern here going up by 4. So you know how that first table has 6 chairs? Well, if I take those 2 chairs off at the end, then I have my table with 4 chairs, and we're going up by 4. So if each of those 11 tables has 4 chairs, I can do 11 times 4, which gives me 44. And then I can add back on those 2 chairs at the end. So plus 2 gives me 46 chairs. And then how many tables are needed to seat 30 chairs? Well, this time we're going to work backwards. So for 30 chairs, I'm going to take off those 2 at the end. I'm going to take off those 2. Just for a minute. So we're going to take off those 2 at the end, and we get 28. So that's 28 chairs. And if there's 4 chairs at each table, we can divide by 4. 28 divided by 4 is 7. So we would need 7 tables. And on page 49, you just had to do 4 and 5. You are traveling down the interstate averaging 50 miles per hour. How much time has passed when you've traveled 120 miles? Well, I know I'm going 50 miles an hour, and we got to get up to 120 miles. I would probably want to draw out a visual on this one. So let's say that this is 50 miles. So 50 miles per hour. This is 50 miles, so it took me 1 hour. We need to get up to 120. So let's go another 50 miles, which makes another hour. But if we go another 50 miles, we're at 150, so we've gone too far, right? So we need to break this one up. Since we need to get to 20 miles, why don't we break it up by tens? So 10, 20, 30, 40, 50? 10, 20, 30, 40, 50. All right, so here's another 50 miles, but each one of these is 10. So 10, 20, there's my 20 miles. Now I know it takes 1 hour to go this 50 miles, but let's break it up. Let's break it up by tens. So if I know that, we're going to break it up into 1, 2, 3, 4, 5 pieces. So if I know 1 hour is 60 minutes, put 0 in there, I need to break 60 minutes up into 5 pieces. So I'm going to divide by 5. And that will give me 12 minutes. So I know that each little section right there is 12 minutes. And I need 2 of those sections. So that'll be 24 minutes. So my total time is going to be 2 hours and 24 minutes. All right, pay close attention to the order of operations to find the value of this. Okay, order of operations, PEMDAS, PEMDAS, PEMDAS. Say it out loud like 5 times, PEMDAS. Got to get this memorized. It's going to help you out a lot. PEMDAS. What this means is we're going to do parentheses first, and then exponents, multiplication and division, and then adding and subtracting. Okay, so let's start with our parentheses. Here's our parentheses. We need to take care of what's inside the parentheses. I see a 10 minus 2, so that's subtraction down here. I also see an exponent, and look, exponent comes first before subtraction. So let's take care of that exponent. 2 to the 3rd power, there's our base, there's our exponent, means we're going to take 2 and multiply it by itself 3 times. So that will look like 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So now inside the parentheses, we have 10 minus 8. And I know that 10 minus 8 is 2. Okay, so that part's done. So now let's rewrite this. We have 26 plus 2 divided by 4 plus 3 times 6. Okay, let's go back to our order of operations. Do we have any parentheses? Nope. Do we have any exponents? Nope. What comes next? Multiplication and division. So let's underline the multiplication and division. That's what we're doing next. 2 divided by 4. Well, that's going to give us a decimal, isn't it? So you can find the decimal if you want to, or we can just rewrite this as a fraction. 2 divided by 4. Remember that fraction line means divided by. And we can actually reduce this down to 1/2. 3 times 6 is 18. So let's rewrite what we have. We have our 26 plus 1/2 plus 18. Okay, and the very last thing is adding and subtracting. So now we can add all these together. So 8 plus 6 is 14. Carry the 1, 2, 3, 4. Should have 44 and 1/2. Final answer.